This is the diagram, and we want to find this angle. First of all, we can see that this angle will also be equal to 20 degrees. They are angles in the same segment. Let me call this angle W. W equals 20 degrees. And what's the reason for that? Angles in the same segment. Angles in the same segment. Angles in the same segment. Now, what's the trick for identifying that? You can draw a chord here. If you draw a chord here, you'll see that that chord divides the circle into this very, very small segment and this very, very big segment. It divides the circle into a very small minor segment, into a minor segment and a major segment. And you now see that the two lines that form angle 20 degrees touch the extreme ends of the chord, and the two lines that form angle W, mind you, angle W is formed at the circumference, and angle 20 is also formed at the circumference. Those two lines touch the circumference. The two lines that form angle W also touch the circumference, and they touch the extreme ends of the chord. That's how you identify the same segment angles. That means this angle and this angle are in the same segment. So angle W equals 20 degrees because it is in the same segment with 20 degrees. Now, what's the next thing to do? If I let me name this angle M. Angle M is equal to 90 degrees. And we can see that that's an angle in a semicircle. This is a chord, this is the diameter, and this angle is in the semicircle. The trick for that is you see that the two lines which form angle M at the circumference touch the extreme ends of the diameter of the circle. So that means angle M is in a semicircle. An angle in a semicircle is 90 degrees. So I'm going to say angle M equals 90 degrees. Angle in a semicircle. Angle in a semicircle. Now, what else do we need? Now that we have angle M and angle W, we can just say, if you look at this triangle, we'll see that these are the angles inside it. This angle, the whole of this angle, and this angle. When you add all of that together, you get 180. So let me name this Y. That's the angle we want to find. Let's call that angle we want to find Y. So I can now say that 20 plus Y plus M plus W plus 28 equals 180 degrees. Angles in a triangle. So that's what I'm going to write. 20 plus Y, 20 plus Y plus M plus W plus M plus W plus M plus W plus 28 degrees equals 180 degrees. And what's the reason for that? Angles, you write it in front of it. Angles in a triangle, the sum of angles in a triangle, and that simply means 20 plus Y plus M is 90 degrees, plus 90 plus W is 20 degrees, W is 20 degrees, plus 20 plus 20 plus 28 equals 180. And that simply means Y plus 20 plus 90, that's 110 degrees, plus 20, that's 130 degrees, plus 28, that's 158 degrees. Y plus 158 equals 180, and that means y equals 180 minus 158, which means y is equal to 22 degrees. And that's it, very, very simply. So we go to the next one. Question, this is question H. That's 3H. Now let's go to number 5. Now let's go to number 5. Let's go to number 5. Let's go to number 5. This is the diagram. The question says ABCD is a cyclic quadrilateral such that AB is parallel to DC. If angle ACD is 35 degrees, that's this angle, and angle DBC is 72 degrees, that's this angle. Calculate the sizes of the angles of the trapezium. Okay, they said the cyclic quadrilateral is a trapezium. It's a trapezium. So we want to find its angles. That means we want to find angle A, angle B, angle C, and angle D inside the cyclic quadrilateral, which is a trapezium. Now what the first thing to do, if I call this W, I can see that W is equal to 35 degrees because they are angles in the same segment. W equals 35 degrees. Angles in the same segment. Angles in the same segment. Now, since I know W, I can find the whole of angle B. The whole of angle B is going to be W plus 72. So angle B is equal to W plus 72. 72 degrees, which is 35 plus 72, and that's equal to 107 degrees. So that's the first angle. So that's one of the angles of the quadrilateral ABCD, which is a trapezium, of the cyclic quadrilateral ABCD, which is a trapezium. Now let's go. Which other angle can we find? Now that I know angle B, I can find angle D, because I know that the opposite angles of a cyclic quadrilateral are supplementary. So that simply means angle D is equal to 180 minus 107 degrees. The reason is opposite angles of a cyclic quadrilateral. I just write quadrilateral in short that way. Quadrilateral are supplementary. So that means angle B plus angle D is 180 degrees, and that means angle D will be 180 minus angle B, which is 180 minus 107, and that means angle D is equal to 73 degrees. Now I found two of the angles already, two of the angles of the quadrilateral ABCD. Now what else can we do? If this line and this line are parallel, if AB is parallel to DC, that simply means this angle and this angle are equal because they are alternate angles. So let me call this M. M equals 35 degrees. M equals 35 degrees. And the reason is because they are alternate angles. Now that we know M, we can also see that this angle, let's call this X. X is also equal to 72 degrees. And the reason is angles in the same segment. X equals 72 degrees. Angles in the same segment. 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 And now we can find angle A. Angle A is going to be x plus m. Angle A, so that therefore means angle A equals x plus m, which is equal to 72 plus 35. 72 plus 35, and that's also equal to 107 degrees. So angle A is equal to 107 degrees. Now we are left with angle C. We know that opposite angles of a cyclic quadrilateral are supplementary. So that means angle A plus angle C is equal to 180 degrees. So that means angle C is going to be 180 minus angle A. So that's how I'm going to find angle C. Angle C equals 180 minus angle A. And the reason for that is opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. So that simply means angle C is equal to 180 minus, what is angle A? 107 degrees. So that's 180 minus 107 degrees, and that is 73 degrees. And now let's check, have we found all of them? We found angle C, we found A, we found D, and we found B. So we found all the angles of the quadrilateral A, B, C, D. And that's it, very, very simply. So let's go to the last one, which is number 9. Question 9b. Let's go to question 9b. There's a diagram. Let's have a diagram first of all. That's a diagram. Let's draw the diagram. This is it. Don't let me make that look like it is a diameter. Let's have it this way. This is a diagram. There's a line here, another one here, and there's a line here. Now let's label the parts of it. Let's label the circle A, B, C, D, and this is E. Now this angle is 60 degrees. This angle is X. This angle is 2x. Now the question says calculate the value of x giving a reason for each step in your answer. So this is a diagram and I want us to find the value of x. Now what's the first thing to do? I can see that, what do we notice? Okay, I can see that BCE, angle BCE, which is this angle, is an exterior angle to the cyclic quadrilateral ABCD. And we know that exterior angle is equal to the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So that means this angle, this exterior angle, is equal to 2x. How do you determine that? If you complete this, you are going to have 180 degrees. So the angle facing what you need to add to that exterior angle to make it 180 degrees is the opposite interior angle. So that's a trick for identify the opposite interior angle. So I can say angle BCE equals 2x. Exterior angle of a cyclic quadrilateral exterior angle of a cyclic quadrilateral equals opposite interior angle. So that's it. That means angle BCE is equal to 2x. So this angle is 2x. And now we can find x easily. X plus 2x plus 60 equals 180 degrees. So I can say x plus 2x plus 60 equals 180 degrees. Angles in a triangle. And that simply means 3x plus 60 equals 180, which means 3x equals 180 minus 60. And that means 3x equals 120. We divide through by 3, and that gives us x equals 40 degrees. And that's it. Very, very simple. X equals 40 degrees. And that's the last one. So you can't miss it if you remember all the rules and you are very careful.